All right, so in this one, we're going to be converting some more logarithms, and we're going to start solving them and looking at the properties for them. And then we'll start condensing to be able to solve. So we're going to be working logarithms, converting it back and forth again. So there are 4 questions for your warm-up in here. So go ahead and do those 4 questions. So pause the video and go ahead and convert those to the form that it's asking for. All right, so if we're converting to log form, the base that holds up the exponent is the 5. I go grab that 125 to come back to the 3. Okay, this one, the base that's holding up the exponent is the 27. We do our flippy and grab the 3 and get it equal to that 1/3. Right, the base in this one is 3. We go past, drop the equal sign in to come grab that 9. Remember, a lot of times you won't see the 10 there. There is always a base 10 if you don't see one. So 10 to the -2 is equal to 100. So just 1 over 100. So just a reminder, the way that we get that, you technically would drop it or do the reciprocal of it to make it a positive exponent. And then that 10 squared is what's going to get us to that 100. Okay. So something that we kind of practiced last class is what happens when we have the same bases on both sides. So what we're going to do is we're going to convert these. To make it easier, we're going to put these equal to y. Because they already have a different variable. If they have an x and an x, it's going to get confusing. So we're just going to make these all y's this time because we have the x's in there. All right, so I want you to pause the video, do your swirly, see if you can figure out what that y variable represents and what it equals. So go ahead and try to represent those. 8, 9, and 10 are going to be our tougher ones. So pause the video if you have it and go ahead and try it. All right, so this first one here, switch colors. I have 3 to the y is equal to 243. So 3 to the y is equal to, I'm going to change those bases to be the same. Okay, this one is going to be a pretty one, but just so that we can see how it works, cancel out those bases to get the fact that it is going to be 5. And my next one, 3 to the y is equal to 5. Today in class, we're going to figure out, well, what happens when I don't have bases that I can change to be the same? I can't get them both to be 3 bases. Okay, so we're going to learn in class today how to kind of work that and find the decimal that works for that. 7 has the shortcut appearing. So if I do it the long way, 9 to the y is equal to 9 squared. Not 2 equal signs. Cancel my bases, I get y is equal to 2. So if I go back in here, there is my shortcut right there. Okay, if I have the same base number and the same exponential, okay, we can cancel and we get our answer, which is 2. So in 8, 9, and 10, all of the shortcuts appear. Okay, I have 3 with log base 3. I have log base 7 with 7. I have base 7 with log base 7. So technically, they're going to cancel and become 1. Alrighty. So if I do it the long way, because some of you might not see that, I grab, this is an exponential. I'm going to convert to log. Yes, there is a log in the exponent. Okay, but its base is an exponential. So I'm going to convert them to log. So I've got log using that base 3. Grab that y, come back to that exponent. So log base 3 of 4x, I think that says -1. It says +1, sorry. Okay, I got the same thing on both sides. Notice I did the same thing with my logs as I did with my exponentials. Okay, so I get 4x minus 1 left. So if I do the shortcut in here, so if I go back and erase all the stuff up here, my shortcut is if I have the same base for both, they cancel and become 1. Whatever is left is my answer, which is what I got my answer to be. Okay, so technically, if I do my shortcut for this next one, it's just going to end up becoming 3w. So let me show you the long way. So this one, I start as a logarithm, so I'm going to convert to exponential. So I use that 7 base to the y is equal to 7 to the 3w. So if I cancel my 7s, notice I got that 3w left. Okay. Same with the next one. My shortcut, I could cancel the 7 and the log base 7 to get x squared minus 1 left. Okay. Otherwise, if I'm actually converting it, I have an exponential as its base. So I'm going to start and go to log. So log base 7 of y is equal to log base 7 of x squared minus 1. Cancel those. Notice what I got left is if I canceled, I get up in here again. And I canceled that, I get that x squared minus 1 left. So that's where once we start seeing that shortcut, it's going to save us a lot of time. Okay? So this just basically says something that I kind of did right here. If I have the same log base on both sides, we can cancel it, just like we do with exponential. So if I have 3 to the x is equal to 3 to the third, we canceled it, it says they're equivalent, and we can solve it from there. Okay, so before we actually go into the meat of this, I want to do a couple questions on this page real quick, and then we'll kind of roll into the rest of it. So on these, when we're solving, we're going to have to check our answers, and some of us don't have that log base button. There's this thing called change of base. So we're going to change the base to be our common log. So our common log is what all of our calculators recognize it as base 10. So if I have this right here, I can do log using base 10 of the argument on top, the base on the bottom. So that's kind of how I remember which one goes on the bottom. I think my base number goes on the bottom. Okay, so now typing it in, okay, I use my common log, it's right there. So it was log of 12 and my parentheses divided by log of 5, my base. Okay, every calculator has our general common log. If you have the log base button, you can use that to check your answers. Alrighty. Otherwise, if you have a TI-83 or an older TI-84, you'll have to go this route. So my answer then is 1.5440 for this one, 1.5440. All right, so now we're going to check our next one. So log of 6. So it is already in base 10. I don't even need to do change of base. It's already in base 10. So I'm just going to do log of 6. Okay, 0.7781 is going to be your answer. Okay, my next one here, if I do my change of base, big font size on top, base on the bottom. So I'm going to do log of 5.5 and my parentheses divided by log of 7. Yep. Okay, so your answer for that, do it to your 4 numbers past your decimal place. So 0.8761. Okay, so go ahead and pause the video and try 3 and 4 on your own. Okay, 3 you can just type in. You could, it is already in its common log, so you can just type it in. So there is your answer. 0.4. Yep. Okay, so there's your answer for the third one. The fourth one, you'd be doing log of 91 divided by log of 5. So log of 91 divided by log of 5. There's your answer for your last one. Okay. The very last thing that we're going to do before we start actually doing our full inverses is these bottom 2 questions here. All right, so remember when we're finding an inverse of an equation, we have to get our x and y flipped. So first step, make sure it says y equals. So we both do. We flip x and y, and then we resolve for y. So in this instance, I have x equals 4 to the y divided by 3. Second step, I did my flipping of x and y. Third step, I need to solve for y. So I can't move the 3. The 3 is in the exponent. So if I'm stuck, I convert to the other form. I'm going to convert to log. So log, the base that's holding up the exponent, holding up the house is 4. I do my flippy. I come back to that y divided by 3. Okay, so then to get y by itself, we multiply times 3 to get my answer. Normally we would write it back in inverse notation, but because it started with y equals, we're not going to. All right, so then number 6 here, I want you to pause the video, try it on your own, and then I'm going to flip the answer up. So pause the video for me. All right, and here's your answer for that one. All right, let's go ahead and solve some of them. So I want you guys to pause the video and try 11, 12, 13, and 14. Go ahead and do your converting to its opposite form. So we're converting all of these to exponentials, and I want you to solve for x. So pause the video. And then I'm going to write up kind of all the answers. We should be used to seeing these by now. This is what we practiced last class. So pause the video for me. All right, so here are the answers for these 4. So I actually typed in 8 to the 4 thirds to get 16. I typed in 4 4 to the 5 over 2 to get 32. Number 13, I had to do some solving. So I took 4 squared. I got 16 and actually solved for x. 14, I canceled out those 8s. You could have also used your shortcut to cancel that out. Just set 5n plus 1 equals 16 and solve for n. So the problem is we also have extraneous solutions again. I talked about how logarithms are positive patties and they don't like negatives. Okay, so we need to just make sure that our answers actually work. So in this, remember extraneous solutions are what give me that error in the calculator. Logarithms do have asymptotes. So just like rationals, there are some answers that don't work. Okay, so we're going to plug it back in and check all of our answers. So I'm going to plug that 16 back in for that x. We're just going to figure out the left side. So if you have that change of base button, that log base button, so if you press math and scroll the log base, you can type it in and then use your math frac button if you want to get it back to that 4/3. If you don't have that, you just do your quick change of base that we now know how to do. You'll get a decimal, and then you can press your math frac button. So let's go ahead and do that. So log of 16 divided by log of 8. And then I can do my math frac button to tell me that it is 4/3. Okay, so we are good with that one. So same thing with this. We're going to plop that 32 back in. Okay, if you do your change of base based on the bottom, okay, or go through your log base button in your math section, should be pretty close to the bottom to be able to check to make sure that is 5 over 2. All right, next one here, I would put in 15 to see if it equals 2. So if you have that log base button, you can go ahead and just type this in. If you're going to change a base route, I would simplify before getting to that point. 15 plus 1 is 16. And then I would actually go through my change of base. If you do a lot of things with your change of base, sometimes it gets a little weird on your parentheses. Okay, so then my next one here, I've got log 8, 5 times 3 plus 1. So same thing, what I would do is simplify in here. 5 times 3 is 15 plus 1 is 16. So when I do my change of base, I have this over this. All right, my next step here, I have logs on both sides, so I can go ahead and cancel and then try to solve this algebraically. Pause the video, make sure your algebra skills are up to par. See if you can solve this algebraically by yourself, and then go ahead and check your answer. You need to throw a little 1 in front to make it easier. You can. So I got x is equal to -3. Now I got to check it. So log 7 of 2 times -3 plus 8 is equal to log 7, -3 plus 5. Okay, so if I simplify here, 2 times -3 is -6 plus 8 is 2. -3 plus 5 is 2. And then if I type log base 7 of 2 in my calculator, it does work. It won't give me an error in my calculator, it'll just give me a pretty ugly decimal. All right, my next one here, I don't have a log to cross out, so I'm going to have to do my swirly. So I've got 5 squared is equal to 2x plus 1. So 25 is equal to 2x plus 1. 24 is equal to 2x. X is equal to 12. Plug it back in and check it for me. So pause the video, you plug it back in and check it. Okay, so if I'm doing that, 2 times 12 plus 1. 2 times 12, 24, so 25. Okay, and then either do your change of base, so log of 25 divided by log of 5, or do your log base. Alrighty. 17 here, I got the same thing on both sides, so I'm going to go ahead and cancel. I don't really need those parentheses anymore because there's nothing in front to distribute. So I've got x squared, x, and a number. I'm going to end up factoring and snowflaking. So I got to figure out what side is easier to bring it all to. Technically, it is easier to bring it to the left. Okay, I'm going to keep that x squared positive, so I'm going to subtract 4x over and also add 3. So I'm going to subtract 4x and add 3. So notice I put it in standard form, x squared, x in my number, so I don't mess up my A, B, and C. So pause the video, try to snowflake this, and find me my 2 answers. Okay, check your answer, and then try 18 because 18 is going to be very similar. And then I'm going to kind of write out the whole answer set. All right, so there's a lot that happened in this. So you're going to see my snowflake on 17. I got my answers as 3 and 1. Big thing is you plug them in separately. So notice I plugged in 3 first. Okay, log base 4 of 9 is going to give me a decimal. I got it on both sides, so that one's fine. Then I plugged in 1 for both the x's on both sides. Okay, I simplified both sides. If I type that in my calculator, I get a decimal again. Okay, if I do my next one, I had to subtract 1p over. I made sure I wrote it in standard form. So notice I put that 1p in the center so I don't mess up my A, B, and C. Okay, I did my snowflake. I got p is equal to 2 and p is equal to -1. When I plugged -1 in and tried to type this in my calculator, it says error, which means he is my extraneous solution. He would not work. He would not exist. Right? So moving on. A lot of times we're going to have multiple logs in them. So we have these properties to condense and expand our logarithms. All right, so our exponent rules come back. So just a reminder, when you take x cubed times x to the 4th, you add the exponents. Okay, so the big thing is addition is going to work with multiplication. Okay, so the way that I remember it is addition kind of looks like a multiplication sign. If we're dividing things with the same base, we normally subtract our exponents. So division then we'll work with subtraction. All right, so the way that I remember it, the division sign kind of looks like the minus sign. All right, we're going to use these to expand and condense logarithms. So today we're going to condense them so that we can actually do our Swirly and solve them. All right, so here are our properties. I just said multiplication. We can separate it and with addition sign, or if you have an addition sign, we can bring it together with multiplication. All right, so if I have things being added, I can actually take that 4 and that 7 and multiply them. Division works with subtraction. So if I have 2 things being subtracted, I can take that 20 and that 5, and I can actually divide them to condense it down or to expand it. The one that tends to be the hardest one is our power property. So if we have an exponent or a power, we can bring it forward or bring it backwards. All right, so if it's in the back, I can technically bring it forward to sit in the front. Or if you have a number sitting in the front, we can technically bring it backwards to represent an exponent. Okay, so our power property just bumps forwards and backwards our exponents. All righty. So for this one, I said plus sign was a lot like multiplication. So when I condense down to 1 log, I write it with 1 log. So I'm going to take whatever is behind it, and I'm going to multiply them together behind that 1 log. Notice I didn't write log base 5 twice. We're condensing, making it smaller. Okay, because now that I'm condensed, I have 1 single log on both sides. I can cancel them, and now I can solve. So this one I would divide by 8 to get 6, and then technically we would have to check our answer. So I'd be plugging that 6 back in and making sure that it's actually true. Most of the time, the only ones we're really worried about are our negative ones. Okay, so my next one here, I got a plus sign, so I write 1 log base 8. I take what's behind it, and I multiply it. All right, I don't have a log on the other side, so to get rid of this log, I'm going to convert it. So I'm going to take 8 to that exponent, and I'm going to come back to that x times x minus 12. Well, 8 squared is 64. And I can distribute this. This gets me x squared minus 12x. So I'm going to end up snowflaking. So I'm going to subtract that 64 over to get x squared minus 12x minus 64. Okay, I want you to pause the video. I want you to snowflake it and find my 2 answers and make sure both those answers work. Alrighty, so here are my 2 answers, 16 and negative 4. Negative 4 will not work because if I plug that negative 4 back in, even right here, I'm going to get a negative log. Okay, number 3, I have a minus sign. Minus is like division. Notice that I put them together. I did not divide it all by 6. It both sits right behind my new log where I wrote it once. Then we can cancel. Okay, I can either cross multiply or I can just multiply that 6 over to get 14 which is 84. Okay, my next one here, I got a minus sign, so I'm going to write, I don't need to even write the 10 because it should be in base 10 or common log. Okay, so notice I put that R underneath the R plus 4. I repeat a gigantic divide sign. I'm going to cancel those logs. Don't really need the parentheses anymore if I don't want them. There's nothing in front of it. What's going to help me is when I get this R over. So I'm going to multiply both sides by R. It cancels here. Please do not distribute it to the top. We are multiplying by it to get rid of it. So I'm going to have R plus 4. It goes to both. So R squared plus 1R. Well, if I want to throw 1 on here, subtract my 1Rs. Opposite of squaring is then square rooting. So I have a plus or minus 2. Remember when we solve in square root things, we have the positive and negative sides. Problem is, we don't like the negative sides, right? We are positive patties. If I plug it back in to this one right here, I would get a negative logarithm. So he would be extraneous. Okay, so go ahead and try 5 and 6 on your own. You can attempt 7. 7 is going to be a little bit difficult, but we should be able to do 5, 6, and 8. So pause the video, try 5, 6, and 8 on your own, and then I'm going to throw the answers up there. All right, so the first one I put 42 over x. All right, I set this up to cross multiply right here. So I just put 7 over 1 so that I can cross. So 42 times 1 on this side. I got my equal sign to 7 times x on the other side. So then I can just divide by 7 and get 6. If I plug 6 back in, it should work. Okay. I then plus sign for number 6 means multiply. So 3x and 5 gives me 15x. Divide by 15, I get 2. The harder one is 8. So if I look at 8 here, I did x times x plus 21. You could distribute if you want to. I'm going to keep it all together until I convert. So I converted. There wasn't a log on the other side, so I couldn't just cancel. So I did 10 to the second is equal to that x times x plus 21, and then I distributed after that step to get x squared plus 21x. Okay, I know that I had a snowflake, so I brought that 100 over. I snowflaked, negative 25 did not work, so I circled 4. Okay, number 7, I can't actually cross log base 5 out because of that 2 sitting in front of it. So what I actually have to do is bump this 2 back using our power rule. So I'm going to bump it back to be his exponent, and then I can cancel out those logs. Opposite of squaring is square rooting, so I would get 3 and negative 3, but my negative 3 would be extraneous, because if I plug him back in, he would be extraneous. Okay, my next one here, I want to get x by itself. So a little bit different because we have an e. Since we're in e, that means my answer is going to have a natural log in it. So if I'm getting the x by itself, I'm going to subtract 1, divide by 5. It's in exponential form. I'm going to convert to log form. So I've got log, the base that's holding it up is e. I do my flippy, and I come back for that x. Well, log base e is the same as natural log. We learned how to do that. Okay, and then you could find the decimal of that. My next one, I've got natural log, so the easiest way to convert it is to give it that log base e. And now I can convert to exponential. So I've got the base is e to the first. We come back, so all I got to do is add 6. Okay, and then find that decimal. So type in e to the first plus 6 to find this decimal. And we can have negatives with those ones. Well, not the natural log, okay, but the exponential, we could probably have some negative answers. Okay, the very last thing we're going to go through is different ways to solve these. So the first way we're going to do it is convert it and do our change of base. Okay, so if I convert this little guy, I already noticed my bases. I can't have a base get me to 45. 9 to some power doesn't get me to 45, okay, and then 3 to some power doesn't. So one way we could do it is just kind of going in to our log. So I would take log of 9 of 45 is equal to x. From here, you guys could use that log base button in your calculator, x by itself, so I don't have to do a whole lot more. Okay, or for those of you that have the older calculators, you just do your change in base and figure out what the decimal is. Okay, option 2, what you do to one side, you can do to both sides, and we can use our rules we just learned. So I could actually log both sides. So I would say log of 9 to the x is equal to log of 45. Okay, but I can't just get rid of that log of 9 to get x by itself because x is in the exponent. So what we're actually going to do is bring that x forward, because remember, exponents can look forwards and backwards. Okay, then it's being forward by multiply, so we can divide it to get rid of it. And notice that is the exact same. Okay, so what I want you to do is pause the video and try the last two on your own, and then I'll kind of flip up my work and my answers and talk through them kind of quickly on the two different methods. So logging both sides or converting it using change of base. All right, so let me flip up to the top one here. Out of my work for this one, so I did log of 5 is 125 or 120, then I did my change of base. Okay, you can kind of see me solving the other one, bringing that exponent forward, dividing to solve it. And then the very last one, this is where the change of base formula comes from, guys. This is how we could do change of base and why it actually works, is method 2. Method 2 shows me that when I use these rules, this is why change of base is going to work every single time. Why that base is in the bottom and that argument is on the top.